planning to lecture on chapter 5 of Management Information System course. And the title for this chapter is the foundation of basic business intelligence, basically it's database. Okay, let's take a look on the learning objective of this topic. Basically, in this topic, at the end of my lecture, I'm supposed to enable you to describe how the problem of managing data resources in traditional file environment in comparison to digital database management system. By the end of the course, you should be able to describe the capabilities and values of database management system and try to apply the principle of database management into a simple design spreadsheet. You should be able to also evaluate tools and technology for accessing information from databases using platforms in big data management, in online analytical processing, in order to improve business performance and for managers making better decisions. You should be able also to assess or to learn about the role of information policy that governs the database access and also information sharing within the organizational setting. Okay, let's take a look on this organizing data in the traditional file environment. So basically, if you take a look on any file organization concept, all databases basically is consisting of a group of related files or a related document. Within that database, just in comparison, just like your normal folder, inside there is files. Inside the files, there are records. Inside the records, there are fields. And within the field, there are two main components, which is entity and also attributes. So basically, database is a collection of file, records, entity, and attributes. So if you go to purchase books at Amazon, you can see many options of book to purchase from, for example. So those are database of books. And if you go to Shopee to purchase a product online, you can see many products being offered. Those are basically databases of product within the database of Shopee server website. So basically, the database is a compilation of many data, which is sorted based on its file name, based on record type, field name, and also its entity and attribute. I would say database exists in many systems and many devices. For example, I believe you have also a database, or simple database on your palm. What could be the simplest database that you may use every day? It could be in the form of smartphone, because if you tap for your contacts in the smartphone, contacts names and phone number, you can see a list of names and telephone numbers. Those are basically a database. So I would say database is predominantly the major component of many websites that we use every day that benefit people to access data faster and more efficient. So database is the intelligence inside many of the system existing every day that we use. Okay, for example, we search at the Shopee website. So you try to search treadmill. Treadmill is a machine for you to do physical exercise at home or at gym. So you search a treadmill and then press enter at Shopee. You could see a list of many treadmills available at the server website database. One would be from this Zero brand. The other one is from this Snowfit brand. The other treadmill brand from Happy Life, Global, and Johnson Fitness. So these are all databases of treadmill which existed at Shopee. So Shopee posted all the treadmill types in the website due to the existence of the list of database entry and product under the Shopee server database. So it is as simple as that. So it is a list of product within the same category shown to customer if they are asking for information. Basically, in terms of data hierarchy, okay, so for data to exist, it must have layer and it must have its organizational structure. For example, this is the database of a student at UTHM database server for student record. Okay, so at the database, there is the first layer. So student database consisting of what are the courses that the student took and what is their financial status and what is their personal information file. For example, name, IC number, metric number, those are incorporated in this layer. Under this database, there is a file. Okay, and inside the file, normally it is keeping the information on student ID, like matrix number, what are the courses that you are taking, for example, BPA 20703, what are the semester or the date, and what grade you have scored inside for the course inside the semester. Under the file, there is record. For this record, it has the following data name. For example, student ID header, course header, date, and grade. So for this student, for example, metric number 39044, it has taken Information System Course 101, and the date is fall semester 6, and it has attained grade of B+. Under the record, it has field. And this field is basically this course field, which is IS 11 information system course that the student took. And inside the field, there is byte. Okay? There is a byte information in which normally this is kept in the information language, and information normally reads in the form of 1 and zeros. Okay, like this byte 01001001. This is letter I for ASCII. For the human language, we treated this number as decimal system 73. So under the byte, there are bits. There are 8 bits inside one byte, as I have explained in previous chapter. So this bit contain all zeros and ones. So basically, information work with 0 and 1s in creating a record, file, and the whole database for human to make use of this data for managers to make a more effective and efficient decision. Okay. Well, in this case, if we keep an information inside the field, for example, character A, character A in the ASCII file tabulated table is represented by 01000001. It is representing A in human language, but in decimal system, it is represented by 065. So basically, computer are keeping a single character with these 8 bits of information of zeros and ones. So these are how the computer keeping the data for the database. Okay, if we take a look on the digital file database and the traditional file database, so basically, definitely it is easier to manage information by using digital file database. Okay, if you take a look on the traditional file environment, like this separate physical file like this, so basically there are many information which is redundant. Perhaps your name, it could appear here, and your name, it could appear at this also file also appearing. So this is called data redundancy, in which many of the same information is kept in several different files. Okay, some of the data might be inconsistent because it is manually keyed in or manually written into this file. So the problem with traditional file environment or database, it is kept in a separate file, and some of the data are repeating, and it is not related to each other. So you have to access file by file in order to find, for example, the names and prices. So in a traditional data file, which is the data are not interrelated to each other. They are separated because it is in the physical form. They are not linked to each other. So in such a traditional file, of course, data is not flexible. It is very much manual based access. And this is what they call standalone traditional file. So this file is not related or linked to this file. Okay. So there is a poor security system in traditional file environment. So you cannot secure because it is a physical file, as it is open for breach or open for data being stolen. And data sharing and availability is also lacking in terms of easiness to share data and smoothness to share data availability. Okay, in traditional file processing, you could see that if there are 4 departments in the company and they are all using traditional file, basically accounting and finance, they have their own file, human resource have their own files and drawer, sales and marketing, they have their own files and drawer, and manufacturing and production, they have their own file and drawer or physical file. However, if we transfer this into a traditional file by using a software, accounting software like a UBS, user business system, we could keep this approach in a more integrated manner. So in which application program 1, UBS, is keeping data, and application program number 2 also is keeping data for human resource. Application program number 3 for sales also their own program, and manufacturing, production scheduling, they have their own application program. So basically, all of these software are keeping their own information system and their own database. So all of these information are very much separated from each other in the traditional file data processing, in which each department keep their own information. Okay, so it is not integrated and it is not dynamically linked. However, in a digital database, in the modern computer environment, so digital database serve many applications by centralizing data and control data repeating or data redundant. So perhaps in just one file, it keeps the name. The rest it keeps the product number. The rest is keeping the production schedule, and the rest is for perhaps sales and marketing. So all these data are actually linked to each other, so that there is less need for data redundancy. So basically, in the modern database management system, there are interfaces between application or between software in comparison to traditional file data. And in DBMS, it separates the logical and physical view of data. So in such a way, you could have a better control of the data and information. So we reduce the inconsistency of data because data are very much more standardized. Okay, this is the graphical outlook of information of database for human resource department, for example. So in HRD database, this is the representation of database with a cylindrical shape. Inside this database, it keeps the employee ID, for example, matrix number, the name, the IC number, the position in the company, when you got hired, what is your total pay, what is your basic pay, what is your overall pay, life insurance, and so on. So inside this database, it is linked into a database management system, DBMS, and from such that structure, it can be split up to the record for name, IC number, and healthcare. And these are the category for benefits. And from this database system, you can separate it with the other uh, uh, category of data in the form of name, IC number, gross pay, and net pay. So inside this digital database, this name and social security number is the same exact information. It doesn't have to repeat by itself. In such a way, this benefit is basically referring to the same name and the same IC number to keep the record for their salary or their payroll. Okay, so as such, a human resource database can be viewed from many perspectives, like from the benefit view or from the, I would say, payroll scheme view. So from the same database source. This is what has been known as relational database. So in this structure, this is called related database, which is this name and SSN is related to this same name and SSN. As such, this view and this view is related, and that is why they call it is a relational database. Basically, in relational database, it is linking data in a two-dimensional table, the X table, X view, and also the Y view, or two-dimensional in the form of X-axis and Y-axis. So each table contains data, entity, and attributes. So to form a table, you need a grid of course, column, okay, and you need another row. So inside this table, basically a row is the one that is horizontally laid. It consists of records for different entities. For the field, inside the column, it represents the attitude, the attribute of the entity. Key field is uniquely to identify each record. There is a primary key and there is a foreign key to link to other table. Okay, this is the structure, how it is laid out inside a relational database. So you have a row, okay, and you have a column, and this is one table. This table is named supplier. Inside this supplier table, it has attributes, okay, and field. So this is the attribute supplier name, and it contains fields 8 to 59. And this is the supplier name attributes, and the field contains information of the company name, CBM Incorporated, and so on. So all these are basically the structure of how supplier table is made. It consists of row, okay, it consists of records, and it consists of tuples. Okay, in this table, the key field is supplier number. This is the primary key, in which if information want to access the other part of the records, then it must go through this supplier primary key, supplier number primary key. The other table is named part. Okay, it has the part number, information, it has part name information, it has unit price information, and supplier number. Okay, in this part table, so it has a primary key by the name of column part number. So this is the basically the primary key for table part. And the other on the right column, it has a supplier number, which is called foreign key. Okay, so if this if information want to access from supplier to this part table, so basically information can be accessed from this table to this part table through the primary key and supplier number, accessing supplier number column in part table, and then you can access unit price, part name, and also the part number. So this is how it works for relational database. Normally it has the primary key, and this primary key column exists on the column of other part table, in which the other information can be accessed. Basically, in the operation of relational database, in order to see many views of many information on other table, you have to select, and then you have to join those what you select, and then you can project what is actually you want to see. So the procedure in the database, you have to decide selection, and then join the selection that you want to see, and then show what are the information that is the only information that you want to see in the view or in the screen. Okay, for example, this is the tree table. The tree table is consisting of the part table, supplier table, right? So this is basically to show the this table of part number, part name, supplier number, and supplier name. For example, you are the cashier or the person in charge, which is keeping the information for a supplying company. So in the computer screen, there are limited information you can show or see at the computer screen. You want to know only what is the part number that customer order, what is the name of the part number, what is the supplier number for you to manage the order, and who is supplying the products. So out of these two table, part and supplier, you want to see only two part number, which is door latch and door molding, part number 137 and 150 respectively. So for this case, you need to select and then join and project. You need to select and then join with other table information that you can combine and let the project only this piece of information. Okay, so in this case, for part number 137, basically door latch. For part number 150, basically door molding. And show me only the part name, which is you can get from here. And show me only supplier number, which is 8259, and also 8263, which is this and this. And tell from the system, tell me or the manager what is the supplier name, which is CBM Incorporated and Jackson Component. So database enable us to see only the information that we need in order, instead of seeing all the information which is available inside the database, which are too much for us to make sense, to make decision. So as such, just select, combine or join with other information which are needed, and then show the needed information on the screen. So that is how the relational database works. Okay, in the database approach to data management, basically there are relational database, some other also non-relational database. Some database exist in the cloud, for example, like Amazon relational database or Microsoft SQL Azure, and so on. There are many types of databases. So in the database management system, there are many capabilities in which mostly the data definition has its own structure so that it can house the content used to create tables or related tables and define characteristic of the field. It has the data dictionary in which keeping the element and characteristic of information together. And as such, you must have the database programming language. They call it manipulation language. For example, SQL language or Microsoft Access. That is also another familiar software. So those are the capabilities for data management system in order to operate. Okay, let's take a look the data structure for Microsoft Access software. For example, if you are setting up the database that we have discussed earlier for the supplier number, supplier name, street, city, state, and postcode or zip. So all these field name must be dictated or must be decided for the computer to keep. For example, supplier number. Mostly it is number like 3278. Okay, for supplier name, it should be data type text, which is ABCD. Okay, and for the supplier street, it should be Roman ABCD, same as city, state, and zip. Zip could be number and alphabet, and as such, it is called text data type. Okay, and we have to set up also the property fields. For example, field size, how it should be filled with information. It should be for field size in the long integer, and decimal places, for example, is set at auto. So in this Microsoft SS database structure, all this information must be decided and must be key into the field in order for the software to work properly. Okay, for example, you have this a query or a request of information. Okay, for example, this is the table for select part, which is this. Okay, from the select part, you can see part number, you can see part name, you can see unit price and supplier number. From the supplier table, you can see supplier name. Okay, and from the supplier where part, which is supplier number, okay, equal to supplier number and part number 137 or 105. Okay, so say you are as an employee, you want to see the part number, these two part number, which is 137 and 150. What you need to do is you have to take the information from here and here, select, and then okay, join it, okay, with the other information from supplier number and supplier name, in which you can get it from here and here, right? So you join it with this information supplier table, and you project it here. So select and then join and project this table, because you want to work only on these two products to be fetched for delivery. Okay, that is how the SQL query works. Okay, so in this Microsoft SS query, basically this part table consisting of part number, part name, unit price, and supplier number. In order to access from the supplier table on the supplier number and name, you have to follow this supplier number. It goes to this table supplier number, and you can access supplier name. So, and the setting of the field table is also set here. For example, part, okay, which is 137 or 150, part, which is a part name. From the supplier table, you are interested on supplier number, and from the supplier table, you are interested only on the supplier name information. So these are the setting at Microsoft Access based on your query. So how to manage this database? What's the approach? Basically, you have to have the design approach. You have to have the process to identify, and you need some sort of rules or normalization in order to access your data. Okay, data can be existing in scattered forms. For example, it is not in the particular order. For example, you have order number, order date, part number, unit price, supplier city, supplier zip. It could be jumbled up. But in order for SQL to work, you need to make it in order and separate it based on category type. For example, this is part which house the information for part number, part name, unit price, and supplier number. And this is the table for line item. It consists information of order number, part number, and part quantity. And this is another set of information of supplier table. It consists of the information on supplier number, supplier name, and up to supplier zip. The other table consists of the order number and order date, because it is basically keeping the information about order. So in this normalized table created form, it has 4 table: part table, line item table, supplier, and order. So this is what they call the the setting has been normalized, which is all parts information are table inside a part table. All line item are consolidated into line item table, respectively with supplier and respectively with order. So this part table has the part number as the key. This line item has the order number and part number as the key. The supplier table has a supplier number as its access key. The order table has the key column as the access for information in the order table. So if you have a supplier number here, okay, you can access the information from the part table from the supplier number. You can access unit price, part name, and part number. From this part number, you can access line item table, which is this is the key part number to access information on order number and also to access information on part quantity. From the order number, you can access the order table because this is the key, primary key for order table, which contain information about order date. So this is what we call the table has been normalized or categorized according to their particular set of information in comparison to the previous data, which is not under specific arrangement of type of information. Okay, this is an entity relationship diagram that show the interlinking between entities. These are the entities like supplier, parts, line item, and order. These are 4 entities. So in the logical diagram, how these 4 tables are interrelated. So basically in part 1, I have explained the relation between supplier table to part table and to order table, and then later connected through a line item table. So in the logical diagram, so these supplier, part, line item, and order tables are all interrelated with this logic. So basically, this supplier information can access information at the parts table, and parts table can access item or information in the line table. However, line item cannot access information in order table. Instead, order table can access information in the line item. In other words, supplier provides parts, and then that part is ordered through line item, and that line item belongs to the order. So these are the entity relation diagram, how those 4 tables are very much linked or related to each other. So it's time to discuss to the next topic, which is part of the component of database, how we can better make use of databases. Basically, databases contains a lot of data, large data or big data. So these data, because they are so big, they are normally in the form of unstructured semi-structured data, because you could retrieve or collect all this data from the traffic of the web, from social media platform, for example, like Facebook, Insta, Twitter, and also from sensors like from the environmental sensor in the cities, for example, like an environmental sensor in the form of particular uh, in the air, particulate in the air, and also from the weather and so on. So since these data are very big, so they must be organized, right? They are big. It could be at the scale of petabytes or exabytes of data. So these data are too huge for typical database to process it. So we have to make use of certain software or application in order to make use of this big data so that it creates meaning and value for managers to make better decision. So database like Amazon, from Amazon, and your purchases by using credit card and so on. So these are contributing to the availability of big data in current decades. And from big data, basically, you can process it in the approach of business intelligence. So there are some tools available for businesses to basically create intelligence out of this big data. So some of the tools available are data warehouses, data marts, using application to process big data like Hadoop software. You could also use in-memory computing based on the RAM's content, and also analytical platform, for example, like R programming. So let's discuss on first tool is data warehouse. Well, the name says by itself that this warehouse stores data, which is current data, asynchronous data, and also historical data from many operational transaction. For example, from the TPS, transaction processing system, so or from any purchases that you make online. So these data are consolidated and later they are being standardized in terms of format or in terms of its structure. So this data basically static. It cannot be altered. However, you can analyze the data, and you can create a standardized reporting tool in order to understand what the data is reporting. The second tool called data marts. Data marts is basically a subcomponent of data warehouse. So it could summarize and focus a portion of the data by using a specific category of users. And normally it focuses on either on single subject or single category of business strategic unit. So this data mart is more focused in comparison to data house, which is more generalized. Let's take a look on this diagram. How does the component of the data warehouse basically interact and related to each other? So as I said earlier, you could use a software application like Hadoop in order to process, categorize, and analysis the data. So this Hadoop, for example, in the data warehouse like from Maybank. So at Maybank server system, it has operational data. It has also transactional historical data that you have purchased through Maybank. It has machine data, data from its website, maybank2u.com. Could be audio and video data, and also external data like from data from supplier and also from customer. All this data could be contributed to Hadoop, which is analytical software, and this Hadoop will access the data warehouse inside the Maybank server. And this data warehouse also got data mart, which is a specific application of transaction, for example, in which engaging users for their queries, report, and also for managers to see their dashboard. This data warehouse also are linked into the users that are using the data inside the data warehouse. For example, users, employees of Maybank that are using queries or search for information, Maybank employees that generate reports, online analytical processing on OLAP, and also data mining by Maybank employees. And this could be engaging analytical platform, for example, like R programming, and they are accessing data from data warehouse at the same time incorporating analytical tools by Hadoop so that they can extract the trend and also give projected reports for the managers at Maybank. So these are all the interrelated linkage of components of a data warehouse in which to make better use and create more meaning on the big data platform. As I told you earlier, Hadoop is an application software, a software system that enable programmers or business and analytical executive to do processing parallelly in the distributed manner for big data collection in order for them to interpret its meaning. So Hadoop basically produces analytical report in the form of this kind of graphical diagram. For example, it could be in the histogram diagram, it could be in this line diagram, and these consolidated data are basically derived or programmed by Hadoop so that managers can have a better value of this data so that they can decide more efficient and effectively. Basically, Hadoop is converting this huge digital data in the form of one and zeros, program it into a particular specific format of result that that the user wanted, and project it into the dashboard or into the terminal so that the manager can see, analyze further, and also to make subsequent decision. So that is basically what Hadoop software analytical platform does. Databases also can use in-memory computing, basically online asynchronous data that is available on the online, for example, during transactions, so that they can basically analyze the transaction, so that perhaps they could reduce the hours or days of processing in terms of purchasing transaction from long hours into second, or make it faster. So in such a way, for inline memory computing to be executed, it must require the optimization of the hardware. Another tool which can be used is analytical platform, which is high-speed platform using both relational and non-relational tool for a large data set as executed by software Hadoop to process big data. Analytical tool basically using relationship and patterns and creating trends so that they could consolidate, analyze, and provide access to very big data for users to make better and more accurate decision, in which they can make use of this multi-dimensional data analysis or OLAP, or data mining, text mining, or web mining. Those are another analytical tool which are available that we can make use of data and information that exists in our database. OLAP. OLAP is basically a synchronous transaction analysis that can be done online. It supports the multidimensional array of data, viewing data using multiple dimension, in which it can be viewed in many layers and in many perspectives. For example, this is a multi-dimensional data model. For example, this is a database. So it has three dimensions. For example, the first dimension is product, which are the product that your company are supplying, like nuts, bolts, washers, and screws. And you want to monitor its sales projection or target actual sales within the region of East, West, and Central. So in which how many nuts we are supposed to be selling, and what is the actual volume that we have sold at perhaps region West. So this is how we could see the three-dimensional data for managers to make decision. So this is the multi-dimensional data model. Another analytical tool is data mining. Okay, in data mining perspective, basically, computer could analyze the hidden patterns, relationships in data sets. For example, customer buying patterns at Amazon. For example, I go to Amazon and I'm looking for books on data analytic. Perhaps I have found this book, Big Data Analytic with Hadoop Tree, right? So I have decided to buy this book, and later I pay, I execute the transaction, and within 10 or 12 days, this book come to my home. So in this kind of data mining, basically, at Amazon, computer programmers can do association, sequencing, classification, clustering, and also forecasting by using Amazon big data warehouse that they have available. So from that big data warehouse availability, by after purchasing this big data analytic book, perhaps in the next few weeks, Amazon will suggest me another relevant bestseller book. For example, this Python data analysis. Python is another software that programmers use to analyze big data. So this book is very much related to this book. As such, Amazon could suggest me newer book later after a few days or few weeks, suggesting that there is another bestseller book in which the same category that you have bought perhaps 2 or 3 weeks ago, so that the system is suggesting me a new one. So this can be executed through data mining of associations. Text mining. This is another typical of a big data analytical approach that we normally in business use. For example, data programmer could extract key element of large unstructured data from your emails, from call center customer feedback in terms of, for example, complaining or quality reports or customer feedback, some difficulty in using the product. Computer programmers also can use legal cases information in order to execute text mining, pattern description, service report, and so on. So these are few approaches by the approach of text, mining the text to create values and new meaning for manager to decide their subsequent business operation. The third analytical approach is web mining, in which the website itself is basically being evaluated or being analyzed for useful patterns, right? Or they can make use of the mining of the web pages, its structure and linkage to other web pages. So these are very much common in current internet world, the web mining, because one website is very much linked or related to other websites. So bottom line is webs and database are very much related. I would say web is the linking of the computer databases all around the world. So basically, these web were powered by web server, and this web server, because it is a network, so it is very much linked to other web server, to the other website, and all website basically are connected to databases. So let's take a look at the linkage between internal databases to the web. So let's give an Amazon company as the example. So say at Amazon.com, here am I, a client at the web browser like Google Chrome or Explorer. I want to search for a book at titling Big Data Analytics. So I have to go to computer terminal with appropriate linkage or network to the internet. And this internet will allow me to be linking to the Amazon web server. And inside this web server, basically there is a software server, for example, for search, for purchasing books. So that is at the level of application server. In that application server, I will search or type the book title that I need. For example, Big Data Analytic, and then I press Enter. So this database server will allow me to search the content information inside this database, and of course, later the system will list me few books which are relevant or which are basically frequently search in on title Big Data Analytic, and from there I will make my decision to purchase, make payment, and get my book. All above all, basically all these data resources must be managed properly. So as such, companies and organizations need to establish its IT policy or information policy. Equally same as our university, UTHM, it has its IT policy. in which the organization engage or decision on what kind of rules, procedure, how to share roles, and how to manage this data inside this big database of the organization. So as such, this data must be administered in the way that what kind of a procedure must be there, how to access information, who could access information, and at the same time, the data must be governed. So the governance must be clear as far as this is how to deal with policy and processes for managing availability, usability, integrity, and security of data. And all these are one of the strong requirement of any organization. That's why in this database administration, you need to create and maintain the database, and to better govern these databases. That's why we have this layer of information access, in which not all people can also access all data. For example, dean and deputy vice chancellor can access higher layer information, and the lower level, for example, like administrator, can access only their level of accessibility for information. That's why we have password, we have particular scheme and mechanism to access data within our own database system. Okay, so data must be managed so that it can be used properly, and managers can decide efficiently and effectively. However, data must be ensured its quality level. So people say garbage in, garbage out. So if you put data discriminately, you put data inaccurately, so you could end up have a wrong data. You could have a wrong report. So data must be kept in a high quality so that it doesn't have redundancy. Data must be consistent in terms of its format, in terms of its approach in keying in, and data must be free from any faults. So as such, we have data quality audit. So for prior data can be keyed in, so it must be audited, or it must be inspected, or it must be filtered, so that we can have good data cleansing, so that only good data can enter our database, so that we can have a good result when we do the query on the database. Okay, my student, that will wrap up for my lecture on Chapter 5, Foundation of Business Intelligence. I hope you have found it to be useful in understanding this chapter. I would like to thank you again on your attention. So, thank you. We adjourn here. Okay, see you later in the next chapter. Thank you and goodbye.